So in this lecture, we're going to start a discussion of finding probabilities for compound events, that is, events that are made up of two or more possible outcomes. Now here, I have just a basic, simple event, right? Find the probability that a randomly selected student has a maximum high school education. That's what I've got in this table here, right? Somebody went out and did a survey. They asked 384 people, what is the highest level of education you've achieved and how old are you, right? And they've summarized the results in this table here. So I want to know, what is the probability that a randomly selected person has high school as their highest level of education? Well, this is a simple probability, right? So this is the number of high school people divided by the total number of people. Well, there's, how many high schoolers are there? There are 259 people whose maximum education was high school, and there are 384 people altogether in our survey results. So there's the result. Remember, we've talked about this before, right? Statistics, probability, it's an applied subject, so we can go ahead and make these into decimals. 3 decimal places will usually be sufficient. Okay, so we want to go beyond this, or we want to go beyond simple events to what are called compound events. And a compound event is any event that's made up of two or more simple events. All right, so let's start right off, jump right in with an example. Right? I want to find the probability that a randomly selected person has either high school or an undergraduate degree as their highest education level. Okay, well, first, you see how this is a compound event now. We have two possible outcomes here that we're considering. Either one of those would be okay. All right, well, let's see. I want to do probability, high school, or undergrad. And what's that going to be? Well, it's going to be the total number of high school or undergraduate people. So I'm going to take the high school people plus the undergraduate people. That'll give me the total that I'm looking for. And again, it's divided by the total number of people surveyed. So let's see, there were 259 for high school, 91 for the undergraduates, still 384 total, and my calculator tells me this is 0.911. So the probability of randomly selecting a person in either of those two categories is 0.911, or remember, we can also kind of interpret these as percentages. 91.1% of the people surveyed had those two education levels as their highest. Okay, so let's try another one here. Right, probability of a person being selected either having high school as their highest education level or being under 21. Okay, I mean, we've kind of got our method now here. I'm thinking this is going to be number of high school graduates plus the number of people under 21. We'll just put the two groups together and divide that by the total. Well, what do I get? There's 259 high school students plus, I'm coming up here, 128 people under 21, and the total is still 384. Well, if you add up that numerator, you get 387 over 384, and that's a problem. Right, we're in trouble right off the bat. Okay, when you think about it, if you don't see why, think about it for a minute. Remember our probability rules, right? Remember, we had a probability rule that says probabilities have to be less than or equal to 1, and that number isn't. I mean, I can tell, right? I mean, you get your calculator if you like, but the numerator is greater than the denominator. That's greater than 1, and that can't happen with a probability. Okay, so what happened here? Well, what happened is this. Look, let me highlight these two groups. The under 21 group, was all of these three, and the high school group was all of these three. This group right here is my problem, is where the problem is happening. They got added twice. They got added once here in the 128, and they got added in a second time with a 259. Okay, so what can we do here? Well, look, I can fix this, right? I can fix this easily enough. Let's cross this out. That didn't work, right? Here's what I'm going to do. I'm going to start the same way. I'm going to do the 259 plus the 128. Now, I know I'm in trouble at this point because I've overcounted. I've counted these 120 students, people, twice. Well, I can fix this by just subtracting them out. I'm still going to be over 384, right? So I subtracted out my duplicates, right? And when I did that, I end up with 0.695, which is less than 1, right? So that works. That's going to be our fix, right? So let's. So the important difference between those two examples is this idea of what we call events being disjoint. Two events are disjoint if they can't happen at the same time, right? In other words, if one person can or can't have both properties. So I've got some examples here, right? Is it possible to draw an ace and draw a black card at the same time? Well, yeah, there are black aces in the deck, spades and clubs, right? Those are both black aces. So these events are not disjoint because it's possible for them to both occur on the same card. All right, being in high school and being 18, is it possible for a person to be both in high school and to be 18 years old? Well, yeah, a lot of people are, right? Most graduating seniors are 18, right? So these events can occur at the same time, so they are not disjoint. All right, and finally, how about rolling a 3 and a 6? Is it possible to roll a die once and have it come up to a side that has both a 3 and a 6 on it? Well, no, the sides are one number each, right? It isn't possible to have both of these occur at the same time, so these two events are disjoint. So what I have here is our formula for calculating an OR probability, right? Sometimes called the addition rule because you add the probabilities together. You see what's happening here, right? I'm going to add the probability of A and the probability of B, and I'm going to subtract the probability of A and B. That's the overlap, right? That would be the 120 students that were in both categories in our previous example, right? So let's take a look at that, right? Let's go back to my table here, right? And I want to find the probability of randomly selecting a people who is either a graduate, who has graduate school as their top level of education, or has an age between 21 and 25. All right, so what is this going to be? P grad or 21 to 25. Well, that's the probability of someone having grad school as their education level, plus the probability of being between 21 and 25, minus the overlap, probability of having a graduate degree and being between 21 and 25. So let's work these out then. The probability of grad school, that's 34 out of the total, 34 out of 384. The probability of being between 21 and 25, that's this 128 over 384 still, minus the probability of being in that graduate school category and the 21 to 25 category. That is this small group here. So I'm going to subtract out those 12. And there you go. Right? That'll give us our answer. One nice thing about these is if for whatever reason you do feel you have to do these with fractions, the denominators are always going to be the same, right, which gives you a little bit of a head start. But we're treating this as an applied subject, so we're just going to go to the calculator. The calculator says this is 0.391, right? And there's my probability. Okay, so let's take a look at this one. Right here, and you can pause if you like. You can try to work this one out on your own, right? Then come back and watch me do it. So we have two events here. I'm going to call A getting a red card, and I'm going to call B getting a queen. Right? So what do I have here? This is the probability of getting a red card plus the probability of getting a queen minus the probability of getting a red queen. All right, well, red cards, that's half the deck, right? So that it's 26 out of 52. Queens, there's 4 of them altogether, so this is 4 out of 52. And there are 2 red queens, right? So I'm going to subtract out that intersection, the and part. So this is going to be, what, 28 divided by 52 altogether, which is 0.538. Okay, so think about this for a minute. That's a little more than a half, right? Does that make sense? Well, yeah, I think it does, right? Because the red cards make up half the deck, and we've got just a couple more cards. We've got the 2 black queens. Right, so yeah, it does kind of make sense that this would be a little more than 50%. All right, so how about this one? Probability of getting a red card or a black card. Right, well, this is probability of red plus the probability of black minus the probability of red and black. Okay, well, red cards, that's half the deck, 26 out of the 52. Black cards, well, those are the other 26 out of 52. Now, how many cards are there that are both red and black? Well, there's 0. These two are disjoint events. They can't both happen at the same time. So this is 0 over 52. And our formula still works, right? Our formula still works even when there is no overlap, when the events are disjoint. So what do we get now? This is 52 over 52, or 1, which is also hopefully what you expected, right? The red cards and the black cards, those are all of them. So it makes sense that the probability should end up being 1 or 100%. Okay, so what's next? What's next? We're going to talk about another kind of probability related to compound events. We're going to talk about what's called an and probability, right? And we're going to do those calculations using what's called the multiplication rule.